Okay. Dude. There we go. Okay. Okay, now what? Desktop audio. Is desktop audio working? How can I test this? Just do Pavu control? I don't want to do that. I'll play last stream. Okay. Wait. Yeah, desktop audio is not working either. Oh, well, is it? Is there just no desktop audio? Okay, what if I play, this Northern Lion clip?
Blame it on
Oh, okay, there is audio. Okay. Alright. Control? I don't want to do that. This Northern Lion clip.
Blame it on
Oh, okay, there is audio. Okay. Alright, cool. So pretty soon I'm gonna have to... Well, first I'm gonna have to work at 10:10, so I'm not gonna be able to study for as long as I'd like, because I have to go to work. But in the meantime, I can study. But also my parents are gonna be coming home and they're gonna be talking and stuff, so I'm gonna have to mute my microphone when they do that. Yeah, 10:10 a.m. is when I'm finishing schoolwork, so then I can get to work by noon. Okay. Okay, I think I can show stuff now. I think we're good. Eight-bit mask? Customer's premises to satellite internet service. Of course, you know, the answer to the satellite question is the only answer that contains the word satellite in it. Stupid distractors, dude. Have some better distractors, dude. A subnet. A subnet is within the subnet mask. Yeah. Show startup config. Let's go. I'm kind of on a roll. Application log. I don't know, dude. This is such a weird... CompTIA has a weird definition of like these different logs. Application log records data for single specific service. The last I remember, application log was described as a log of all the actions of applications on a server, which isn't what I thought application log meant, and I'm pretty sure isn't what a lot of people think application log means, but you know, that's their definition, right? So, I'm gonna say I don't know, can't record errors, maybe? Okay. Records data for a single specific service. That's crazy. That's crazy. Because, hold on. No, I'm not gonna do this. It's stupid. It's stupid. Is there like a... Sure, I'll watch this.
On your network, you're probably using routers, switches, firewalls, and many other network infrastructure devices, and all of these devices are running 365 days a year, 7 days a week, 24 hours in every single day. We'll need to monitor these devices to make sure that they remain up and running, and we may want to query those devices to determine what type of load they're seeing, perhaps log file information, and other details from each individual device. This allows us to see if people are able to authenticate properly to the device, if there are any security concerns, or how much utilization.
Does this have what I want in it? Like, does this describe what an application log is? How much application traffic? Talks about APIs? What?
And may be used in CPU or network. Many times the network is switched to be able to gather that information. There will also include application traffic is traversing the network. These are the top 5 application details associated with each traffic.
Okay, it might be valuable to watch this anyways.
Routers, switches, firewalls, and many other network infrastructure. Of all of this different information from these many different sources, put everything on one single screen for analysis. One of these data points gathered by this network management station could come from a service known as NetFlow. NetFlow is a summary of statistics based on the flows of traffic that are traversing the network. NetFlow has a standard way to collect this information from these devices, and there are many...
And NetFlow is a Cisco thing, right? Yeah. Wow, 1996. As of 2012, technologies similar to NetFlow are still in use. Okay, so like NetFlow itself isn't really... I don't know, all I'm saying is it says a lot that the most recent, you know, entry into its history section is as of 2012, you know? Like, I don't know. Okay.
NetFlow products available from many different manufacturers. NetFlow usually starts with a probe that you would put onto your network. This probe may be sitting in the middle of a connection using a physical tap, or maybe using a switched port analyzer interface on a switch to be able to gather that information. Raw packets are being sent to this NetFlow probe, and that NetFlow probe is compiling statistics based on all of the packets going across your network. The summary of all of that information is then sent down to a single NetFlow collector. This means you don't have to go to separate NetFlow probes to be able to gather all of this detail. You go to the single collector, and you can create all of your reports from that one central place. The collector is not only keeping a database of all of this information at the time, but often the collector will also include a report generator. This might allow real-time reports and summary views on your console, or you may be able to configure long-term reports to be generated every day. This is a NetFlow console, and the current screen is showing a NetFlow traffic analyzer summary. You can see that it contains top 10 conversations, which are ingress and egress data for all of these devices. This is over the last hour. You can also see a top 10 endpoints on your network. This is listed by IP address or the name of the device. Here are the sources of that NetFlow data, and you also have traffic analyzer events that are coming from those NetFlow devices. NetFlow can also summarize information by port number so that you can see how much application traffic is traversing the network. These are the top 5 applications on this network. Looks like SSL is the largest amount of traffic on this network, and then there's SQL Server, other web traffic, NetFlow UDP traffic, and port 0 traffic. All of that NetFlow information is effectively metadata that was created based on the packets going across the network. But you can also view the raw packets themselves using a protocol analyzer. This allows you to see the exact bits and bytes sent from
like
one
Wireshark
device to another. Protocol analyzers can collect frames from a wired network, a wireless network, and it can present this information in a form that is easy to read. Instead of viewing all of the hexadecimal data, you can view a summary of these packets going back and forth, and then drill down into the details associated with each packet. If you're trying to find unknown traffic or you're working to troubleshoot a slow application, you can view all of the conversations taking place over the network using this view inside of your protocol analyzer. And in some organizations, this data is also collected and stored over a long time frame. This usually includes a very large array of storage drives, and every packet from the network is being stored on those drives for later analysis. Once we begin gathering all of this data from these many different data sources, we can start building a picture of what a normal day on the network might look like. We refer to this as a network performance baseline, and this can be a very useful set of statistics, especially when we begin troubleshooting the network. If you're trying to determine if a large amount of utilization on the network is normal, you simply look at your baseline to know what the normal amount of utilization would be during a standard workday. You can then compare that to the value you're seeing now, and then determine if that's better or worse than what would normally occur on the network. We can also drill down into these baselines to see what normal performance might be for an individual device, for example. So you're able to get a very detailed view across many different devices on your network by simply compiling this data into a central baseline. If your organization is using a management console or a SIM, this would be a security and information event manager, then you may already be collecting data files and other useful statistics that you can use to build out a performance baseline. This management console or SIM console may be able to look through the data and identify an alert when certain anomalies occur, or it may be able to present normal baselines for an extended period of time so that you can see when things happen to change over a normal workday. That management console or SIM console is collecting log files from many different devices. There's log files inside your switches, your routers, your firewalls, your servers, and practically any other device you would connect to the network. There is a standard way to transfer log files from all of these devices, even though each one of those devices may be manufactured by a different company. This standard for transferring log files is known as syslog. You'll usually see the syslog configuration inside of your switch or router, and you'll tell the switch or router where to send all of its log files using that standard syslog transfer. This is commonly sent to a SIM, which is a security information and event manager, and usually we are storing that on a large drive array inside of that SIM. That SIM is identifying what device sent that log file. It'll identify what's known as a facility code, which is the program that originally created that log file, and it will also include a severity level for that line within the log file. So you should look at the configurations in your enterprise switches, routers, and other devices to see what options you might have for sending that syslog information to your SIM. If you were to log into that security information and event manager, you would find a large amount of information available to you. It's not just page after page of this log information, it's also all of that information rolled up into reports that you can then use to make decisions. For example, there might be a dashboard on the SIM that gives you a real-time status of information about your network. You can see alerts and alarms if there happens to be a large number of failed authentications, or if a device happens to go offline, you may see that in the dashboard of your SIM. Most SIMs also have very advanced reporting capabilities, so you may be able to go back in time, start comparing and contrasting different statistics across multiple devices, all using that large database that you've compiled within the SIM. So you might be able to track application usage when it starts on a server. You can track that traffic as it traverses a switch, watch that traffic as it goes through a firewall, and then analyze how much utilization that's taking on your internet. And since you've now stored all of this log file information over an extended period of time, you might be able to use it for forensics. This will allow you to go back in time and track when someone may have authenticated to the network and then which services they may have used when they were logged in. This log file information can be sent from nearly any device. This could be a NetFlow collector, it might be a server that has syslog capabilities, or it might be a switch, a router, or firewall that's currently running in your infrastructure. One of the things you may find when you first turn on a SIM and start sending it syslog data is that it will be receiving a large amount of information. Some of this information might be useful for that individual device, but it may not be necessary to store that for a long period of time within your SIM. So you may want to change some sensitivity settings on the SIM to be able to perhaps only capture warning or urgent information, and perhaps not store informational details within the SIM database.
I've experienced a lot of stuff like this in the context of my Pi-hole setup on TrueNAS. If you don't know what Pi-hole is, it's sort of a DNS server that you can run locally, and it's called Pi-hole because it's sort of a, not only is it a DNS server, but it's also a sort of traffic filter. It just blocks certain, DNS like domain names based on like regex filters or like just exact match filters and stuff like that through these big block lists that you implement, like these tracking block lists or whatever. And so I've sort of been able to intuit this idea of normal network traffic, and you compare it to like when something weird is going on, and the idea of the SIEM. SIEM. I don't know why he's not saying SIEM, but that's pretty interesting because it's like, I guess if you do have a lot of sort of entry points or a lot of different devices or a lot of different like stuff, it would make sense to like sort of integrate it into one place to look at it. And with that, you can use filters and stuff. So you're sort of aggregating all of you're sort of aggregating all of the information, and then you're able to like filter down, as opposed to like having the information like on all these individual devices and then having to like go through all these different places to like discover an issue. That's interesting.
Here's an example of an ad hoc data query made on a SIM. You can see that we're doing a query here for anything that starts with fail, so this might be failure or failed, or the word fail itself, and any records that include the word password. So we're looking for situations where password authentication has failed or is not completed successfully. And you can see the series of statistics that are gathered. This creates a single chart across the top, and then we can view individual event records. For example, these appear to be event records from Windows Server, where there's a login failure. It says unknown username or bad password. The username used for that authentication was Haxor. You can see it's Acme text domain, and it has a login type and other lines associated with that record. We can now track this over a long period of time to see, is this normal, or have there been instances during the day when there's been a large number of failed authentications? This might be able to identify times during the day when there would be a brute force attack or a password spraying attack, and then we can use additional security tools to track that closer or to prevent that event from occurring again. If you've ever had to administer a switch, a router, a firewall, or any of these other infrastructure devices, you know that you would normally SSH into the device, perform a series of commands at the command prompt, and then disconnect. And if you need to make that change again on a different switch or router, you will need to SSH to that additional router and make those changes again. This is something that can be relatively tedious and almost impossible to manage in large environments where you may have hundreds or even thousands of these devices. For that reason, we need some way to automate this process, and we can do that by using API integration. This allows us to have a central management station communicate directly to a switch, a router, a firewall, or some other device using an application programming interface, or API. This allows us to create applications, scripts, and other programs that can communicate directly to that device without using the SSH console or communicating to that device over a web console. This means that we can effectively communicate with the native language of that device. So we can send commands, make configuration changes, or query information on that device without having to interactively log in or sit at an SSH prompt and look for that information. And if you're managing those hundreds or thousands of devices, you can make those changes automatically with one click of the button using this application programming interface. A lot of the monitoring and features we discussed in this video needed the raw packets from the network to be able to gather those statistics. One of the ways to gather those packets is using port mirroring. This allows you to use an existing switch and redirect traffic from one port on the switch to a packet gathering device that you have connected on a different port on that switch. We also use port mirroring for security features such as an IDS or IPS, and we may also use this for performance monitoring. For example, we might connect a NetFlow collector to one of these port mirrors. Some switches even support the ability to mirror traffic from one switch to another, so we could have a switch in the data center with our monitoring systems and be able to gather packets from a network switch that may be in another building or another location. The port mirror may also be referred to as a switched port analyzer or SPAN, or we may have a physical network tap that's connected somewhere between two devices. If we are using a switch, we're simply taking a copy of this data and sending that copy to a third-party device such as an IPS or NetFlow collector. So when a user is communicating to a server, they first are communicating through a switch. So a copy of that data is sent to our IPS, and the original copy of that data is sent on to the server. We can do this for single interfaces or multiple interfaces or VLANs on the same switch so that we're able to see all of the traffic that is available on
Okay, sure. Uh, 2 kilometers? Probably single mode, right? Probably multi-mode fiber for internal and then single mode fiber for external. What? Really? Single mode fiber for both? But isn't multi-mode fiber cheaper? Like, isn't it less? Isn't it less to deal with? Like, isn't there less? Isn't there sort of less points of failure for multi-mode fiber? Or like, okay, what? Okay, a mode is like the wavelength of light that's going through the fiber sort of channel, right? So multi-mode fiber just means that like multiple different sort of wavelengths of light can go through this cable. But single mode fiber is, only one type of light can. Is that true? Hold on. Yeah, right? More cost effective. But I guess within a data center you would want like as high speeds as possible. I don't know. I'm gonna ask Gemini about this one. Gemini's a little sycophantic. It's kind of bad vibes. Hmm. Hmm. Okay, that makes sense. I'm gonna do a typing test. It's over. Dude, that was crazy. Oh my god. Oh, and my parents are home. Okay, I'm gonna mute my microphone. It's referring like physically to the OSI model. I see. I see that why that would be wrong because it's referring to like a connectivity issue, and so at the bottom of the OSI stack there is physical layer, so that would make sense. I thought it was just asking what the significance of MX records are, not specifically the priority value. That makes sense. Oh, it's like it's like the width of beams that an antenna is sort of willing to capture. But what does that have to do with directionality? What does directionality mean? Directivity? Is that describing what this is? I think this is what this means. Okay, what? Wow, I had no idea. I thought it was something inherent to the dish. I thought it. That's really incredible. Wow. Okay, my parents are gone again, so I can have my microphone on. What? Oh, okay, I see. Okay, yeah, so you would do like, so if you have SNMP available, you would do it to where it can only be accessed through like, administrator machines. Okay, V3 did encryption. Oh, this costs money now. What? Hold on. This didn't used to cost money. uh... Man, would you look at that? Okay, I mean, that's fine. I'm okay with, it charging me 1 cent to answer a question. But I hadn't realized. Man. Oh, God. 254. Would that be, I forget what, 224. Okay, it's definitely not 3. It's definitely not 1. It's definitely not 2. It's gotta be 4. Okay. That one's just intuitive. What? Oh, the last step. I thought it said first step. Whoops. I need to read the questions more. You're designing a network for a large conference event. Man, I made way too much coffee. I'm not eating until work, so I just kind of hope it doesn't, you know, come back up. You know what I'm saying? With all that acidity. I don't know. Would it be I'm inclined to say number 1 or number 2 because those look the least likely to be a like a DHCP scope for, like, you know, public use or like public use of a network. I'm gonna go for 1 because I've seen more sort of LAN what's it called, the network part of it, IP address. I've seen 1. I've seen, oh, I don't know. Actually, wait, no, I've seen 198 less often than 192 because 192 it's like 192.168.1.1, which is like a lot of routers IP addresses. I'm gonna go for 198. I could be way off. Okay, sure. What? Huh. What? Search. Wow, really? Oh man, I see. Okay. All right. Okay. So it's just that the rest of these like are definitely not for what's being described in the question, but this one definitely is. And you know, it could interfere theoretically, but the rest of these definitely aren't the ones you should be using. So just sort of by process of elimination. Okay. That makes sense. System Kerberos. Directionality. ACLs. And document findings, because it's the last, not the first. And that one, because the rest are weird. Alas, alas. Availability monitor, check for in an HTTP service. To confirm availability, 200, right? Yeah, 200 means it's working. Time standards does NTP use? UTC? Mid-sized corporation. One morning, several employees report that when they try to access a company's internal portal, they are redirected to an external website that looks similar, as for credentials in a suspicious manner. Upon investigation, you suspect a DNS spoofing attack. What are the most immediate and effective actions to take? Well, I don't think increasing security settings on the corporate firewall would prevent an internal page from... Oh, wait, but it goes to an external website. If it goes to an external website, you actually can do the firewall. Okay. Most immediate and effective. It might actually be 4. Increase security settings on corporate firewall and update antivirus software. It might be it, because increasing security settings could include, just completely disabling that, and then update antivirus software, because you don't know what else this random website is doing. I'm going to say 4. Really? It was 3? Huh. But, like, what if something on your network is wrong? Like, what if... Immediate and effective? Like, I don't know. What there was sort of there was, like, already a breach. Like, wouldn't you want to isolate computers? I guess updating antivirus software doesn't really do anything. Like, updating it, like, unless like, the fingerprints of, like, the malware that could have been on this website are outdated, or unless, like, the sort of fingerprint list of malware on the antivirus software is old enough to where there's, like, new malware on this website that was downloaded on the computer and the antivirus software doesn't recognize it. But you wouldn't, like, if you're infected by a virus, the first thing you do isn't update your antivirus software, right? And plus, that could probably, frankly, make things worse, because, in the process of updating the antivirus software, there might be new executable files created, and maybe, in that process, the malware could, worm itself into different exe files, right? But I'm not sure. Because it was asking for the most immediate and effective actions, and because several employees were already visiting this external website, updating antivirus software and because employees were already visiting this website, updating antivirus software could improve security definitions to detect possible malware from the website asking for employee credentials. Also, increasing security settings on the corporate firewall could mean blocking the website that it's for employees to preventing people from Sure. Well, sure, but it could also have malware on it. I guess, you know, the question would have said, okay, sure, sure. Okay, I gotta check its thinking afterwards. Right. This is definitely something I've noticed. Like, if you have a question and you have multiple choice answers, it's fairly, and you don't know exactly what the answer is, it's fairly common that the answer is the one that includes the technologies that are mentioned in the question. You know, this one mentions, you know, DNS. It's fairly likely that the answer is going to be oh, fuck. You know, the question mentions DNS. It's fairly fair. It's reasonable to assume that the answer is going to be 2 or 3 here because 2 and 3 mention DNS directly, and DNS is mentioned in the question. So from sort of like a meta angle, that's understandable, and I agree with what it's saying here. What was it thinking? This thing loves saying zeroing in. It says it like 3 times in the thinking summary. Okay, sure. I guess that makes sense. What is the purpose of monitoring individual interface statistics? Time to live. The funny thing about TTL is that it actually has nothing to do with like the passage of time. I think it is like the maximum. I think it's the maximum hops, right? The maximum number of routers. Yeah, right. Could be wrong. Yeah, yeah. God, why is it called TTL if it has nothing to do with chronological time? Fiber optic cable. Main advantage, higher bandwidth. What does an access key contain? One generated by the server's security service for an authenticated user. An access key generated by the server's security service. What does it contain? I guess I don't really know what it contains. What does it contain? The access key, what does the access key contain? I guess I could imagine maybe password and login time? Username and group memberships. What is this referring to? Oh, my parents are home, and now we also have a baby this time. So now my parents are home with a baby. So I'm going to mute my microphone, and I might have to be right back for about 5 minutes to say hello to the baby, and also I'm going to have to stop streaming at about 10:10 a.m. So it might be like pretty soon after I'm done. Be right back in. Okay. It's like 4 minutes until 10:10, which is when I was planning on stopping studying. So I'm probably just gonna stop now because I come out to use the restroom, and I wouldn't want a little extra time to get ready and to record my video. So yeah, thanks for the short.